Hi there, it's Mrs. Tellas. So this is the video for section 6.1, day 2. We're going to multiply powers with the same base today. So we're going to learn the rules for that. So these are, actually I'm going to skip these. So we're going to go here. So I can prove that these are correct. Okay, I can prove that because when powers have the same base, you could write them out. So x, 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 and x, 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 x. So there's 3 of them and 5 of them. So altogether there are 8 of them. Okay, so here we would multiply negative 2 times 3, which is negative 6. And on the a's, I could prove it by doing a, and then 6 a's over here. And if I add them together, that's to the 9th power. Okay, so if I look at this one, same thing. 10 times negative 3 is negative 30. And then if I look at the A's, there's 2 A's and 4 A's. So A, and A. And then there are 3 B's and 6 B's. So B, and 6 of them. And then if I add them up here, so that's 2 plus 4 is 6, and that's 3 plus 6 is 9. So this is the correct answer, and I can prove it by writing them out. So hopefully you're figuring out that when bases are the same, you can just add the exponents when you're supposed to be multiplying them. And then if you have normal coefficients, like 10 times negative 3, you just multiply those like you normally would. Okay, so here's an example, 2 to the 3rd times 2 to the 5th. If I wrote it out, that'd be 3 2's and then 5 2's, so that's altogether 8 2's. But I could also do it with the rule, which is since they have the same base and I'm multiplying, I could add the exponents, and that would give me 2 to the 8th power, which 2 to the 8th power, let's use Desmos for 2 to the 8th power because I'm not sure what it is. So if we go to Desmos and the calculator, so 2, and then I use this a to the b to get my exponent in the 8th power is 256 as my answer. So 256. Okay, and if it's a number that can be evaluated, I do go ahead and evaluate it. If it's a variable, that would be simplified. There's nothing I can do with that other than leave it that way. So the rule says you keep the base number the same and you add the exponent. So if you want to press pause and copy the rule down, that's probably a good idea. All right, so now we're just going to practice. So if they have the same base and they are being multiplied, so same base and multiplied, we're going to add the exponent. So this is x to the 6 plus 4, which is x to the 10. And this is a to the 8 plus negative 3, which is a to the 5th. And then bases are the same, so negative 4 to the 6 plus 3. So negative 4 to the 9. I don't know what that is, so let's look at Desmos again. And you have to use that parenthesis. So how do you use a parenthesis here? Can I move this? No. So parenthesis. Let's try it without the parenthesis. So there are things in the way here. Negative 4. Now I forget what it was to the 9th power. So I know it's going to be negative because that's an odd number. So to the 9th power. And that's negative 262,144, or 262,144. Okay, now this one is different because see how the bases are not the same? So you can't just add exponents. In order to do this one, you would actually have to evaluate them separately and then multiply their 2 answers. So 3 to the 5th power, I don't know what that is, so let's look it up. So 3 to the 5th power is 243. So 243 would be the top number. And then this one is unhappy, so we move it to the bottom and then evaluate it. So 2 to the 5th is 32. That's my answer. So the trick doesn't work if the exponents are not the same. You just evaluate them separately. Over here, bases are the same, and I'm multiplying, so 0.2 to the negative 5 plus 9, so 0.2 to the 4th. Again, I don't know what that is, so 0.2 raised to the 4th power, and I want the fraction, not the decimal, is 1 over 625. Actually, we could probably do the decimal here since it's a decimal to begin with. Actually, let's just stick with the fraction. So 1 over 625 is my answer. And then the last one here, same basis. So this is negative 10 plus negative 2. So that's 3 to the negative 12. He's unhappy, so I move him to the bottom. So now I just need to know what 3 to the 12th is. So 3 exponent 12, 531441. Let's see if I can remember that. 531441. 531441. So there's my fraction answer. Remember, no decimals here. No decimals. And then the last one, these are all different. So 3 and 2 are different. That's just 6. And Z and A are different. So you can't do much with them. You're just going to list them. I'm going to put them in ABC order. So A squared and Z to the 4th. This would be my answer. Notice I didn't add their exponents because they have different bases. Okay, so here's some more. Just like them, so we're going to multiply. So 3 times 6 is 18. That's normal. And then for the exponents, x and x have the same base. I keep it. And then I do 4 plus negative 2. Oh, it's 18x to the 2nd. And then if I do the numbers, let's see, 3 times 2 is 6, times 4 is 24. Just multiplying those normally. And then this is a to the 1st. So a to the 1 plus 4 plus 3. So my final answer is 24, a to the 8. Because I just added the exponents because they were multiplied and they had the same base. And then if I look here, and I took the highlights away, so 5 times 2 is 10. And then I'm going to combine my a's. So that's a to the 1 plus negative 10. And then I'm going to combine my y's because they have same base. So, nope, no highlighter. So y to the 7 plus 1. So that would be 10a to the negative 9 and y to the 8, except this guy is unhappy. So he goes to the bottom, or the opposite part of the fraction, which would be the denominator. So 10y to the 8th is fine where it's at, and a to the 9th goes to the bottom. All right, number 4. So if we multiply negative 3 times 6, that's negative 18. Negative 18 times 2 is negative 36. And then these two have the same base, so I can combine those. So x to the 4 plus negative 2. And y's on his own. He doesn't have anybody to get with or be combined with because there's no other y's. So negative 36. Whoops, we need the x first because of ABC order. So x to the 2, y to the 2 is my final answer there. So all I'm doing is multiplying the numbers, the coefficients correctly at the front. And then I'm looking for the ones that have same base and I'm adding those exponents. That's really all I'm doing. Okay, so here's a few more. Press pause and try these by yourself and see what you come up with. And then I'll go over them real quick. All right, so 2 times 3 is 6, and then I can combine these n's. So that would be n to the 3 plus negative 3, which is n to the 0, which is just 1. So 6 times 1 is 6. So my final answer is just 6 on that one. And then here, let's see, negative 4 times 7 is negative 28. Negative 28 times 2 is negative 56. And then I can combine the c's because they have the same base. C to the 3 plus negative 2, and the d squared is on its own. So that's negative 56, c to the first, d to the second. That's the correct answer. I don't need the first. I'm going to take it out because usually we don't write to the first power. It's not wrong if you have it, though. And then the coefficients 1, 1, and 12. So the front number is 12. And I've got a j squared and a j to the first power. So that's j to the 2 plus 1 and k to the negative 2. So let's see, 12 is fine where it's at, j to the third, because I added those two. K's unhappy, so he is going to move to the bottom. So there's my final answer. And then this is kind of an enrichment one. If you take a look at these, it's a multiply problem. They all have the same base, and you're adding the exponent. So this would just be x to the a plus b plus c, and that's actually the answer. Kind of abstract there. All right, it says Tammy says that x squared times x to the fourth is x to the eighth. Is she correct? So no, she's not correct because I'm not supposed to multiply exponents. I'm supposed to add exponents when multiplying powers. So she should have done x squared multiplied by x to the fourth is x to the 2 plus 4, which is x to the 6. She multiplied these and got 8. We should have added them because if we want to prove it, there'd be 2 x's in the front and 4 x's here. And if I'm gathering them all up, which is what I'm doing, I have 6 of them. That's why. Okay, so you're going to go on to Canvas now, onto the module. There's a homework that I wrote, and it's in the quiz form, but it's not a quiz. It's just a homework. I think you have three tries for each one to get them correct, and that'll be what your homework is. I think there are about 12 questions on that for today. So thanks very much. Have a good day.